No, I don't want to do the same thing.
Whether that team had someone who wasn't on vacation at the time or maybe sign up for hands-on lab. So sometimes don't always interpret it if there's not a hands-on lab for specific technology. That this is not strategic. It could be, Bob was in Hawaii. So he wasn't checking his email. But I'm glad we do a hands-on lab. I think certainly the functional programming concepts are something that we are looking very deeply at. I think one of the things from a computer architecture perspective for the next couple of years that I think all of us are going to be grappling with is the change from Moore's Law, from being processor speeds are doubling to the number of cores in the system start doubling. And probably all of us for our laptops have dual core machines today. You can see for iPhones right here, they have 3 cores, I think. 3 or 4 or 5 years from now, we're all going to have 8-core laptops or higher. And there's this challenge, which is the traditional way that you do programming doesn't scale across those multiple cores. And so you write a for loop, or you work with state, or you work with a variable today, which we all do. That is not going to grow exponentially as you add cores, and in some cases, actually, performance will go down, which is very counterintuitive. And so, part of it is trying to figure out from a runtime execution perspective, what are things that we can do with the CLR as well as the graphics stack to handle that better. If you look at things like WPF and you look at things like Silverlight, we've done a lot of work in changing the programming model for UI from being traditional paint pixels on a screen to being what's called retained graphics mode, which means that you sort of say, here's a button or here is a graphics context, and the rendering layer takes care of when to repaint and when to redraw. And one of the benefits of that is we actually parallelize our rendering architecture across multiple cores for you automatically. And so even though you don't think of yourself when you drop a button on the form and you drop a data grid on the form as writing multi-core rendering code, you are. And that hopefully just makes it easier for you to take advantage of cores without having to write a lot of code. I think, at the same time on the CLR side, we're doing a lot of work around garbage collection across multiple cores and being a little bit smarter in terms of how we allocate objects and can we make predictive guesses about which heap we're going to work on, and can we do a collection, can we avoid having to pause execution across multiple processes to do it. And you're going to see more work around jitters, and there's a lot of engine infrastructure you can do. Fundamentally though, if you have code which is writing for loops using local state variables inside that loop, though there's limits to how much we can actually parallelize that code stream. We can't tell whether there's a side effect in that code, and ultimately that means we're going to need to scope it to only run on one core. And in a world where if you have 128 cores in your laptop, probably will be within 10 years, that means you're only using 1/28 of the actual processing power of the machine. And that's where I think functional programming is going to come into one area that functional programming is going to come into play, is having a concept where instead of having to try to describe how you want something done, you instead describe what you want done. And so you think about things like link. A lot of people think of it as, hey, it's a cooler way to do SQL, but it's also a way when you express a query, you say, from P in products, where P dot product ID equals 5, select this. You're not, you can do that before each loop today. That's when you're describing how you want to go searching. When you're actually describing a link, you're describing what you want to search for. And we can actually, in the longer term, we'll be able to take that and parallelize it across multiple cores. So potentially we could say, hey, there's 100,000 elements. Let's clone 100,000 elements, and across 128 cores, let's split up 100,000 elements 128 at a time, search for that, find all the results, and combine them back. Hypothetically, that can make things faster. So the idea of functional programming, again, expressing kind of what you want as opposed to how you want, means that the runtime level can actually do much more optimizations for multi-core. It sounds all good in practice. We're still, feeling our way through it, and part of the challenge is coming up with runtime optimizers that actually do the splitting and actually make it faster as opposed to worse. There's a bunch of parallel extensions that we're adding in .4 to actually try to handle multi-core scenarios better. There's some parallel link work that we've already started to put out in CodePlex that's going to go towards that path. And then functional languages like F# are important because they actually, at the language level, introduce it. So F# is very important for us from that perspective. You're going to keep seeing us, though, add functional programming concepts in the traditional language like in C# as well. So we're not going to have the functional programming language and the non-functional programming languages. We're going to start to see that bleed everywhere. Because we think it's an important concept that every language will be able to take advantage of. You know that?
No, it doesn't.
Of course, into the dynamic language front. And that's definitely another area like functional programming that we're investing in. And you're going to see, again, on that front, you're going to see a number of investments. So we've been working on this concept of the DLR, which kind of provides kind of a bunch of infrastructure that any language can plug into in order to kind of enable dynamic types. You're going to see a lot more work. We're starting work right now in terms of looking at the jitting side and at the code generation side of some infrastructure work that we can do to make the DLR even faster and play kind of runtime tricks that can actually really optimize those scenarios. And then at the language level, we are going to do both, like we're doing with F#. We're going to have true dynamic languages like JavaScript, like Python, like Ruby. But then you'll see us, like we're doing with C# in terms of adding dynamism into the static languages as well. I don't. There's people that will always say it should always be static. People will say it should always be dynamic. I think there's actually benefits to both. Yeah, and there's certain scenarios where you can also for dynamic concepts like commenter, that I think I wish with V1 would actually get dynamic done more in terms of making it easier to do kind of dynamic dispatch and com interop without requiring TLPMs or PIAs. There's a lot of work we're doing in .NET 4 so that you no longer have to have every app have its own set of PIAs and you can do a lot more sharing. Having the ability to do dynamic with C# means that you can actually call into Office VBA components without having to even create a TLPM. And it also means that for a lot of scenarios where whether it's duck typing or other scenarios that you want to be able to take advantage of, not having to know the type ahead of time when you do it. So those are definitely going to be areas that we invest in. But you'll also see, I think Link is a good example also of a place where it looks very dynamic in the code, but it actually retains the static type nature. And so you get IntelliSense, you get all the code optimizations that you can get through jitter and things like that. So, and with languages like C# and VB, there's always going to be a nice blend. And I think that blending is good. Hopefully, my model's always, there's three things that are all really good. Take all the good attributes of all of them, leave out the bad ones. Usually things are better. Yeah. We gave that JD Cool game on sort of Silverlight business applications, and it was kind of a little bit of a futurist talk. And so we have a lot of work going on in that space, and hearing a lot more about it and the user head. We kind of want to make sure that we kind of finish maturing that and had it all nicely put together before we kind of go out and push it hard. But that talk was kind of a precursor based on all the feedback. People are really excited about it, which is good. In general, you're going to see for both of them, and Silverlight. I think one of the challenges that we have today in building in-tier applications is the amount of friction or the amount of skills that you need to learn in order to actually move around. And in many ways, one of the reasons I think a lot of people with .NET build applications with ASP.NET is it's possible to build a multi-tier application with ASP.NET in a very two-tier way. And by that I don't mean you have data code coming directly from your page, but it means basically, I can instantiate a business object or a repository, and it can talk directly to the database, and I'm not having to go through an intermediate middle tier route. I don't have to figure out latency, and I don't have to worry about intermediate security, and I don't have to worry about caching validation. And there's a whole bunch of stuff that you kind of don't have to worry about in that. Whereas if you have a client app, whether it's a WinForm, WPF, or Silverlight, you need to think about web services, you need to think about validation of the client and the server, you need to think about concurrency, you need to think about validation, you need to think about a whole bunch of concepts. And I think in .NET today we have a whole bunch of pieces necessary to do that really well. but we can kind of, throw a couple thousand pages of manuals at you